Hello, people interested in the shape of the Earth. While researching this subject, I found lots of data and ideas, but no video name just like this one, so I thought of creating it myself. I know other people, such as the globebusters, have considered the idea of the non-Euclidean geometry. If you think someone has already done a better presentation elsewhere, please direct me to that place. In all of the debates I heard so far, both globe and flat earthers, and I know less about concave earthers, assume their favorite model occupies an Euclidean space, meaning that Euclid's fifth axiom is true. However, as we know from the mathematicians that used alternative axioms, other spaces are theoretically possible. To my knowledge, there is no authority we as humans can ask about the truth of any of these axioms, so we have to rely entirely on our own measurements and calculations. So let's start from the fundamentals. We live on a surface, and we would like to know how this surface looked if we were thousands or millions of times larger than we are. We start measuring and we gather tons of data. Which model fits all of this? It looks like, on a small scale, the space is Euclidean. The mathematician Gauss made an experiment involving 3 mountain tops, the longest distance being 107 kilometers. I haven't read all the details of this experiment, but the conclusion does not surprise me. At this scale, distances still seem to behave like our drawings on a table. However, when we talk of continental sizes, the sum of the angles in such large triangles greatly exceeds 180 degrees. For a while I was tempted to contest this because at these scales we take as reference the magnetic field or points outside the Earth's surface, such as the Sun or stars. All of these references involve some kind of non-linear movement relative to the surface of the Earth, so they could upset measurements. However, we also have long-distance flights that can function as a direct measurement. Interestingly, Rob Skiba made a video about the famous Santiago-Sydney flight. He looks at the Gleason map and argues that we should not make simple Euclidean measurements on it, but instead follow the size distortions indicated by the longitude lines. People then said that this proves the globe model, since the azimuthal map is a projection of a globe on a flat disk. In my opinion, this begs the following questions. As surface inhabitants, how can we distinguish between a Euclidean sphere and a non-Euclidean flat disk? Which measurement results support only one of the possibilities? What is clear to me is that the Euclidean sphere has a measurable curvature and very clear, easy to understand poles. In fact, these are the two major debate points involving the Earth's surface between the globe and flat Earth models. At this point, it is not entirely clear for me what we should expect to happen at the so-called edge of a non-Euclidean disk. Interestingly, in a presentation in Berlin, Einstein explained that his theory offers two possibilities for the universe: infinite or finite. For the finite possibility, he proposed a non-Euclidean space that has no boundaries, and he offered the analogy of a sphere projection on a plane for easier visualization. I remember pondering these concepts longer ago and concluding that they are complex mathematical philosophical constructs without relevance to the daily life. Now, knowing I can dare to question the monstrous extraterrestrial space we are told that surrounds Earth, I can start considering again the non-Euclidean concepts. In other words, what if our visible universe is as simple or as complex, depending how you view it, as an astrolabe? What if we live on a non-Euclidean plane and other non-Euclidean planes rotate above us? What if all the lights we see above are not at all the giant distant bodies we learned in school about? Could all honest observations fit in this kind of model? All star, sun, moon measurements might be accounted for in this way. So, is everyone right? People that do careful earth and sky measurements and see they do not fit in a Euclidean plane conclude automatically that the globe Earth must be true. People that see no curvature and are scandalized by the enormous speeds and distances of the common heliocentric model conclude that Earth is flat. Some observations convince other people that we in fact live on the inside of a globe. Can we all gather all the data in a common model? Could the non-Euclidean astrolabe be the basis for such a common model? In case you're interested, some plans I have on this subject include: understand the details of the non-Euclidean disk and its correspondence to Earth and sky maps. See how electromagnetism fits in with all of this. Study the polarization of the sky. Do lake and mountain experiments for curvature detection. Thanks a lot for watching. Please let me know what you think.